You've already graphed a lot of lines, so let's look at linear functions really closely. The only difference really is that we're using f of x instead of y. We're calling it a function. Y is a function of x. And we're using slope-intercept form, mx plus b, which is most people's favorite anyway. So let's graph these two functions. Pause the video and graph these two functions. We got the first one graphed. We're going to start the second one, edit, oops, I did this one first. The red one is 2x plus 2. The purple one is going to be 2x minus 1. Negative 1 is its y-intercept, so I'm going to go up 2 over 1 to take care of the slope. Notice these lines have the same slope because the m is 2, so these two lines are parallel. Parallel lines have the same slope. They have different y-intercepts, though. Y-intercept is the b, the place where it crosses the y-axis. So let's look at these two examples. Negative 5x plus 4, f of x equals negative 5x plus 4, or y equals negative 5x plus 4. What's its y-intercept? Pause the video and figure it out. Its y-intercept is 4. Let's look at this function. F of x equals 6.3x minus 7.8. Remember, we're looking at the form mx plus b. b is the y-intercept. So negative 7.8 is the y-intercept. But what these really mean are they mean a point on the graph. So if we're talking about the point, we would say it's the point 0, 4, or the point 0, negative 7.8. If we look back here on the one that we graphed, you can see it's the point 0, 2, or the point 0, negative 1, the coordinates. So we can write it in coordinate form or say that b, the y-intercept, equals 4. M is the slope of the graph. It's the steepness of the graph. If the slope is less than 0 or negative, if the slope is negative, the line goes down from left to right. It'd be like you're walking down a hill from left to right. If the slope is positive, we go up the hill from left to right. If the slope is 0, a 0 could just rest right on it. The line is horizontal. You should remember also that a vertical line has an undefined slope, or no slope. Remember, we draw Mr. Slope Man. You can see his mouth is horizontal, so it has 0 slope. His nose is vertical, it has an undefined slope. See the U? And his two eyes are positive and negatively sloped from his eyebrows. So we also think about the slope as a rise over run, the change in y over the change in x. So let's look at this line, this example here. Pause the video and see if you can do it. If we're going to graph the line containing negative 4, 3, and 2, negative 5, and find its slope, I'd find its slope first. So we're going to say change in y, so y minus y over change in x, x minus x. 3 minus negative 5 is 8. Negative 4 minus 2 is negative 6. Simplify your fraction, and your slope is negative 4/3. Let's erase Slope Man so that we can graph this function. See you later, Slope Man. Get ourselves some x and y axes. And usually we start at the y-intercept to graph with the slope and the y-intercept, but we don't know what the y-intercept of this function is. We just have two random points. So let's use one of the points. It doesn't even matter which one. How about negative 4, 3? Negative 4, 1, 2, 3, 4, 3. And then my slope is negative 4/3. The thing you need to remember is with a fraction, it doesn't matter if the negative is here or in the middle or at the bottom, so you could call it a negative 4, or you could call the 3 negative, just as long as one of them is negative. So I'm going to start at my point, and I'm going to go, actually, I'm going to call this 4 over negative 3 so I can fit it on my graph. I'm going to go up 4, 1, 2, 3, 4. I'm going to go to the left 3, 1, 2, 3. And that's how we graph our line. Slope can be used in real life. In real life, it's a rate of change, like miles per hour. Your speed is a rate of change of your position over time. Excuse me. Graphs usually show growth over time or decay over time of different things. So you can see that this is a linear graph. This health insurance premium increase is linear. And you can see they increased steadily in recent years. In 2000, the average premium was $6,438 for a family. By 2008, the amount had increased to $12,680 per year. So we're going to find the rate of change. First, we need to think, what's the y and what's the x? Well, the x value is going to be the year, and the y is going to be the dollars, right? So we want the change in cost over time. And that'll be my slope. And the slope will represent the rate of change of the insurance over time. So let's find the change in cost. And that's a 6. 12,680 minus 6,438. That's going to be the difference in cost. And how many years have passed? Let's see. 12,680 was in 2008. See how I line up the ones that go together? Like if this is first on top, this has to be first on the bottom. Make sure that you do that. And then in 2000, so that's a total of 8 years, we'll see. Pause and calculate. So we end up with $6,242 change in cost over 8 years. If we divide this out, we'd find the amount of change in cost per year. That'd be $780.25 per year. Try this example. So we look at the change in the y values. The y values here are the billions of pieces of mail. So 213.1 minus 202.7 is 10.4. And 2006 minus 2008 is negative 2. And then if we want to know, so that means it went down 10.4 billion pieces of mail in 2 years because the slope is negative. So if we divide that out and find out how much it went down per year, we would get negative 5.2 billion pieces per year. Page 204 and 205 in your book, numbers 1 through 35 odd.